everyone, Christina here from the Glaser Tutoring Company. Welcome, and today we got a good one for you. We're going to be solving a system of linear equations, two variables. We got a word problem, which is everyone's favorite. Word problems are a little bit tricky because you have to make the formulas yourself, and then you got to do the math. But we got this. All right, so let's dive in here. So it says, admission into an amusement park for 4 children and 2 adults is $116.90. Wow. This was probably written in the 90s. There's no way is 4 children and 2 adults coming into an amusement park for a little bit over $100. No way. But anyway, let's keep going. For 6 children and 3 adults, the admission is $175.35. Yeah. Now it says, assuming a different price for children and adults, what is the price of the children's or the child's ticket and the price of an adult ticket? Okay. So the big piece of advice that I could give you is always write down your variables first. So in this case, go to that question. They're asking for what's the price of the child's ticket and what's the price of the adult ticket. We don't know, right? All we know is that they are a different price. So give any letter, right? Usually when we have variables, we got to give them a letter. A, B, C, X, Y, Z, right? Usually with math, it's always going to stem from X. So let's start there. So I'm going to say X equals. And since they said, what's the price of the child's ticket first, I'm going to say child. So X equals the price of a child's ticket. And now we also need to find out what the price of the adult ticket was as well. And since they are different prices, right, it said assuming a different price for children and adults, I can't say that this is X again. If it's both X's, that means that they are going to be the same exact price. So you got to use a different letter. So maybe if you say X, then the next letter comes Y, right? X, Y, Z. So we'll say that the Y is the price of an adult ticket. Price of a child, I guess, yeah. So price of an adult's ticket. Cool. All right, so here's our variables. Now, with systems of equations, the main key thing here is that the total number of variables that you have equal to the total number of equations you have to give. So since we have 2 variables, we need to write out 2 equations. So now we start back from the top and we read again to pick up those cues to find out the equations. So let's write equation 1 here. So equation 1, start from the top. They say that admission into an amusement park for 4 children and 2 adults is, use those context clues, right? Now, we have 4 children, and we don't know the price of the children's ticket. So we're going to say that it's going to be 4 times the children's ticket, which is X. So this would be basically 4X. Literally and, right? And means addition. So we have 4X plus 2 adult tickets. We don't know the price of the adult ticket. That would be Y, but there's 2 of them. So this would be 2 times Y. And use your context clues. Is literally means equals. So by using wording, they're giving it to you as a formula, right? 4 children, 4X, and plus 2 adults, 2Y is equals 16.90. So there's your first equation. So let's just write it out. 4X, so 4 times X, plus 2 times Y equals 1690. When you're dealing with equations, you don't have to put the, dollar sign. It just gets a little confusing if you do. But you have the first equation. Now let's keep reading through to get my second equation. And here they go again. For 6 children. So 6x and means plus 3 adults. 3y. The admission, here's that word is again. So that's equals $175.35. So here we go. 6x plus 3y equals 175.35. So now we got our two beautiful equations, and we have to figure out how to get x and y equals, right? So there's a couple of methods to, solve systems of equations: substitution, addition, elimination. And in this case, we won't use substitution, because usually if you have substitution, we can substitute out an x or a y. But usually you'll do that when only one equation has just one x value or one y value. But in this case, since we have 4 x's and 6 x's and 2 y's and 3 y's, let's not really use the substitution method. But instead, maybe we can get one of our variables to be the same number. Now, we could either work with the x values or the y values, because ideally we want to cancel one of these units out. Now, me personally, I like to work with lower numbers because it's just easier for me. So I look at the 2 and the 3 of the y's and I say, what's the next number that these have in common? Yeah, you got it. A 6, right? I could take a 2 and times it by 3, and I could take a 3 and times it by 2, and I'll get 6. So that's what I'm going to do with these equations. So we ultimately are going to try to get our y values to be the same. We get them to be the same because we want to cancel them out. So in this case, I can take my first equation and times it by 3, because 3 times 2 is 6. And then the bottom, I'm going to times it by 2, because 2 times 3 is 6. And then both of these are going to be 6y, and we could cancel them out and then work with our x values. So if we do that, what I'm going to do is I'm just going to make my new equations over here. You got to be fair though, right? I got to times that 3 by each value in my equation, and the same thing with the 2's. So if I do that, we're now going to have 12x plus 6y, and this is going to equal, let's see, 3 times 1690. So we get 3.50 and 70 cents. I'm just going to put the 70, but you could just put the 7. And then for the bottom one, we have 12x plus, there's the 6y, and it's going to equal 2 times 175.35. Ooh. Something interesting is happening here. Because here's my equation 1, and here's my equation 2. Everything is identical, right? So if we are going to use the elimination method, which is what we're going to do, elimination just means that you're going to subtract your two equations. So if we do subtract, let's see what happens. And you have to subtract all of your variables. So we're going to be subtracting with the x's, we're going to be subtracting with the y's, and we're going to be subtracting with the known values that are on the other side of the equal sign. But when I do that, 12x minus 12x is a big fat 0, so those go bye-bye. 6y minus a 6y, that's a big fat 0. There's nothing on this side of the equal sign anymore. 0. You lost your variables. So lost both variables. But now, on this side, 350, 70 cents and 350 and 70 cents, that goes bye-bye as well. So 0 minus 0. What does this even mean, right? We were trying to find out the price of the child and the adult ticket, right? What does this mean? Well, if you have 0 and the same number on both sides, this basically sums up your answer for you, in which you will have an infinite amount of solutions. So my answer might be different from yours, which means that we can just make up the total of what the adult ticket is and then use our formula to find out what the child ticket was. Now, the only thing is that you just can't go over these amounts, right? So let's just say that, I don't know, let me just maybe make this a little bit higher just so that we can, what happened there? So let's just say that, I don't know, maybe an adult ticket was, I don't know, $20.50, right? If we do that, we can use one of our formulas to solve for the x value. So maybe I'll use equation 1, right? Equation 1 said 4 times x plus, now I know that I have 2 adult tickets. So that's 2 times 2050. And that's going to give me $116.90. So just solve for x. 4x plus, this would be, what is this, $41? Right, 2050 times 2 is $41, and that equals 116.90. So we subtract the 41, that goes bye-bye. We are now at 4x equals 116.90 minus, minus 41. So that's $75.90. We're going to divide by 4 on both sides. And roughly, I mean, in my case, right, we get roughly about $18.98 because there's no such thing as $9.75 unless you go to the gas station. So we have x equals $18.98. So in this case, did I put $81? 18. So in this case, if I made my adult ticket to be $20.50, the child ticket will going to be $18.98. But the thing is that if you put in another value, you'll get a different child ticket. And both answers are correct because according to the math, we don't have enough information to know exactly the child ticket and exactly the adult ticket. So for this question, it's up to your discretion. You could have made the adult ticket, I don't know, $15 and see what this was. You could make this $40 and figure out what this one was. So that's the main idea here, and I hope that helps. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. I look forward to helping you in more questions. Yeah, you guys rock. Tell your friends, tell your classmates about this channel. Just gets the word out there that this channel exists, and I thank you so much, and I hope you're having a great, great, great day. Also, I would like to give a huge shout out to Maricela. Thank you so much for being a member to the channel. Your support means a lot to my brother and me, and we're thrilled to have you be a part of this amazing community. Memberships are open on the channel, and if you want to become a member, just click that join button, which can be found below on any video if you're watching on your desktop, or it can be found on the overall channel page too. For all of you that want your name shown in the video, don't forget to choose the gold tier or higher. Thank you so much for considering, and have a great day. Talk to you in the next lesson. Bye-bye!